Good morning. Welcome to Bharat Institute of Higher Education and Research. My name is Bhaskar Dhanaraj, Assistant Professor, Department of Computer Science, Bharat Institute of Higher Education and Research. Today we are going to discuss Computer Vision Introduction, Image Processing Foundation. Subject code Bcs007. Computer vision is an interdisciplinary scientific field that deals with how computers can gain high-level understanding from digital images or videos. How computers gain understanding over images and videos that occurred from digital sources and equipments. From the perspective of engineering, it seeks to understand an automated task that the human visual system can do. Understanding in this context means the transformation of visual images, that is, input to the retina, into description of the world that makes sense to thought process and can elicit appropriate action. This image understanding can be seen as the entangling of symbolic information from image data using models constructed with the aid of geometry, physics, statistics, and learning theory, mathematics. That is, images are occurred from digital equipments like commercial cameras, drone cameras, medical equipments, and CCTV cameras. Those images are processed, and those processed images are obtained some information. That information having more property and more information than the normal images has. The scientific discipline of computer vision is concerned with the theory behind artificial system, that is machine learning, that extract information from images. The image data can take many forms, such as video sequence, views from multiple cameras, multi-dimensional data, scanner data, medical scanning devices, etc. That technological discipline of computer vision seeks to apply its theories and models to the construction of computer vision system. This computer vision must behave similar to human vision. For that, we are applying so many theories, algorithms, mathematics to make the computer vision similar to human vision to identify objects. Some domains of computer vision include scene reconstruction, event detection, video tracking, object recognition, 3D positioning, learning, indexing, motion estimation, visual surveying, modeling, and image restoration. So these are the various subdomains, that is, these are the various other disciplines where computer vision is involved. Scene reconstruction, in most of the times, in high-level graphics, it is applicable. Event detection, that is, any motion detection applications are using computer vision. Video tracking, object recognition, in an image to recognize some objects, to recognize some edges, we can use computer vision. A typical process of computer vision is acquiring images from digital resources, processing those images to get more information from the original images, analyzing those information and understanding about the informations about the images and extraction of high dimensional data from the real world in order to produce numerical and symbolic information. Evolution of computer vision. Computer vision, even though it is new, even though it deals along with machine learning, it's an old technique. In late 1960s, began at the universities which were pioneering artificial intelligence. It was meant to mimic the human visual system as a stepping stone to endowing robots with intelligent behavior. In 1966, it was believed that this could be achieved through a summer project by attaching a camera to a computer and having it describe what it saw. This is the first work done in 1966, and this is the stepping stone for computer vision. What distinguished computer vision from the prevalent field of digital image processing at that time was a desire to extract three-dimensional structure from images with the goal of achieving full scene understanding. In 1970s, formed the early foundation for many of the computer vision algorithms that exist today, including extraction of edges, labeling of lines, polyhedral and non-polyhedral, representation of objects from the images, and smaller structures, interconnections, optical flow, and motion estimation. So these are the various algorithms formed in 1970s. The next decade, some more rigorous mathematical analysis and quantitative aspect of computer vision developed. This includes the concept of scale space, the inference of shape from various cues such as shading, texture, and focus and contour models known as SNAKES. Researchers also realized that many of these mathematical concepts could be treated within the same optimization framework as regularization and Markov random fields. Recent work has seen of various features-based methods used in conjunction with machine learning techniques and complex optimization frameworks. The advancement of deep learning techniques had brought further life to the field of computer vision. The accuracy of deep learning algorithms on several benchmark computer vision data sets for task ranging from classification, segmentation, and optical flow has surpassed prior methods. The very initial process of digital processing is acquiring images from digital resources. Digital resources are image sensors or imager is a sensor that detects and conveys information used to make an image. It does so by converting the variable annotation of light waves into signals. Convey the information. The waves can be electromagnetic radiation. Image sensors are used in electronic imaging devices of both analog and digital types, which includes digital cameras, drone cameras, mobile cameras, camera modules, optical mouse devices, medical cameras, and medical imaging equipments, night vision equipments, CCTV cameras. So these are the various image resources that offers images. As the technology changes, electronic and digital imaging tends to replace chemical and analog imaging. Processing of images. The occurred image is exported with the help of tools, some of the image acquisition tools, and that should be processed with various techniques available in digital image processing. That means processing digital image by means of digital computer. We can also say that it is a use of computer algorithms in order to get enhanced images from your original images that contains noise to extract some useful information as well. The processing mainly includes three major steps, that is importing the image via image acquisition tools, analyzing and manipulating the images, and output the results and can be altered image and report based on analysis. Various image processing techniques. That is, the very first one in image processing technique is diffusion. That is anisotropic and paranormalic diffusion. It's a technique aiming to reducing image noise without removing significant part or vital part of image contents. Typically, edges and lines or other details that are important for the interpretation of images will not be removed. Only the noise and the grains present in the original image will be removed with the help of diffusion. Image editing. Image editing is a basic technique to enhance your original image by applying filters, diffusion, restoration, etc. Altering images that obtained digitally or traditionally with the help of editing tools. In recent days, we have so many editing tools available and so many apps available for mobile to modify, to alter our original images. Image restoration. The operation of taking a corrupt or noisy image and estimating the original image. Corruption may come from many forms: motion picture, motion blurs, noise, camera misfocus. So these are the various mistakes that tends to corruption of original image that can be recovered with the help of image restoration. Image restoration is performed by reversing the process that blurred the image, and such is performed by imaging a point source and use the point source image. That is called point spread function. to restore the image information lost because of blurring process. Filtering process is another a very famous processing technique that removes noise most of the times and enhance image of the original obtained image. It enhances the quality of the image. It enhances the sharpness of the image. There are various filters available in recent days that you can play with those filters and you can edit your images obtained from original image resource. Pixelation. In computer graphics, pixelation is caused by displaying a bitmap or a section of bitmap at such a larger size that individual pixels, small single color square display elements that comprise the bitmap, are visible. Such an image is said to be pixelated. Point feature matching. Point feature matching is pointing a feature or pointing a particular area in an original image, pointing a particular person in an original image. So that technique is point feature matching. In image processing, point feature matching is an effective method to detect a specified target in a cluttered scene. This method detects single object rather than multiple objects. For instance, by using this method, one can recognize one specific person in a group of persons, but not any other person. Let's come to the process of analyzing the images. Image analysis is the extraction of meaningful information from images, mainly from digital images, by means of digital image processing techniques that we have seen so far. Image analysis can be as simple as reading barcode tags, or can be sophisticated as identifying a person from their face, or maybe a pattern matching, or maybe a object identification. So these kind of analysis can be done with the help of various analyzing algorithms. Computers are indispensable for the analysis of large amount of data that require complex computation for extraction of quantitative information. Human visual cortex is an excellent image analysis apparatus that whatever we see, we can identify what it is. But computer vision is not like that. We need to train the system for that particular object. Especially for extracting higher level information, more training is needed for computer vision. But for human vision, not like that. Human is by birth intellectual property, but computer we need to train to make that intellectual property. Many applications, including medicine, security, and remote sensing, human analysis still cannot be replaced by computers. That is because of the intellectual property by birth. For this reason, many important image analysis tools such as edge detectors and neural networks are inspired by human visual perception models. There are various techniques involved in image processing, that is, filtering operations, thresholding, edge detection techniques, and corner and interest point detection. Classical filtering operation. Filtering is a technique for modifying or enhancing an image. That is, by removing the noise and by removing the blur present in the image will be reconstructed with a fine tune. For example, you can filter an image to emphasize certain feature and to remove certain features. Image processing operations implemented with filtering, including smoothing, sharpening, and edge enhancement. Two major divisions of filtering, that is low pass filter, also known as smoothing, and another one is high pass filter, which is edge detection and sharpening. Low pass filtering is employed to remove high spatial frequency noise from a digital image. That is, with the help of low pass filter, we can remove the noise and grains present in the original image. The low pass filters usually employ moving window operator, which affects one pixel of the image at a time. Changing its value by some function of a local region of pixels, the operator moves over the image to affect all the images, all the pixels in the image. So with this help, we can smoothing the image and we can increase the quality of the image by reducing the noise present in the image. High pass filtering, which is edge detection and sharpening. A high pass filtering can be used to make an image appear sharper. These filters emphasize fine details in the image. The opposite of the low pass filter, but high pass filter works in the same way as low pass filtering works. It just uses different convolution algorithms and kernels. The next technique is thresholding technique. It's a simple but effective way of partitioning the image into foreground and background. This image analysis technique is a type of image segmentation that isolates objects by converting grayscale images into binary images. In this diagram, we can clearly see the image is reconstructed and it separated the foreground and background. The first image is multi-level thresholding and the second image is set level thresholding. The first image, we can see so many colors to represent your foreground and a major color to represent your background. The next image, the same, but it represented in black and white. That is, it follows only black and white to represent foreground and background pictures and foreground and background informations. Edge detection technique. Edge detection technique is another technique to identify or to draw the edges of the original image. This is possible with the help of finding the boundaries of objects within images. And it works by detecting discontinuities in brightness with an algorithm. Edge detection is used for image segmentation and data extraction. In areas such as image processing, computer vision, and machine vision, this common edge detection algorithms are used. The most famous edge detection algorithm is Sobel and Canny algorithm. Other than Sobel and Canny, we have Privet, Roberts, and Fuzzy Logic's algorithms for edge detection. The first image that shows edge detection is applied by Sobel method, and the next one is Canny method. So here in this diagram, you can see the edges are drawn and it makes the information visible to identify features. Corner detection. Corner detection is another technique used within computer vision system to extract certain kinds of features and infer the content of an image. Corner detection is applicable frequently in motion detection, image registration, video tracking, image mosaicing, panorama stitching, 3D reconstruction, and object recognition. In motion detection, this corner detection is very useful to identify a particular object. And in image registration, it is also applicable to register what the image is or to identify what the object is. Most of the smart CCTV camera use video tracking, where the person or an object moving in CCTV camera that captured with the help of CCTV camera, and it will be displayed the motion present in the video. The next one is interest point detection. Interest point detection is a recent terminology in computer vision. If you see any images or if you see any videos, if we want to identify some particular point, if we want to identify some information of a particular point, in that case, we can use interest point detection. An interest point is a point in the image which in general can be categorized as follows. It has a clear, preferably mathematically well-founded definitions. This is one of the example of interest point. It has a well-defined position in image space. The local image structure around the interest point is rich in terms of local information contents. For example, 2D texture, such that the use of interest points simply further processing in the vision system. It is stable under local and global image domains as illumination, brightness variation, and high degree of repeatability. Optionally, the notion of interest point should include an attribute of scale to make it possible to compute interest points from real-life images as well as underscale changes. So these are the various image processing foundation techniques: filtering, edge detection, thresholding, and point detection, corner and point detection. So these are the various processing techniques that increases the quality and information of the images that obtained from digital resources. Based on the images, we have so many algorithms to analyze those images. That algorithms can obtain some information where the exact quality of image and the exact informations present in the image will be obtained from that processing. Acquiring, analyzing, processing, understanding, and extracting high level of information from a digital resource is all about the basics of computer vision. Thank you.